An arithmetic series involves taking an arithmetic sequence or an arithmetic progression and adding the terms up. For example, if our arithmetic progression or arithmetic sequence is 3, 5, 7, 9, 11, 13, etc., we recognize this is an AP because we have a common difference. Then the accompanying arithmetic series will just be the same numbers, but instead of the commas, now we are adding them up. We're finding the sum. Obviously, if this continues forever and our common difference is 2, then our arithmetic series will be infinity, because these will sum up to infinity. We will never stop adding. If we're going to add up the terms of an arithmetic sequence, we get an arithmetic series. Well, as we saw, if we have a common difference, 1 or greater, then we're going to have an infinite sum, or an infinite series. So we want to define how many terms we want to add up. So we'll say we might want to add up 10 terms, or 20 terms, or something. So S to the n is the sum of n terms of the series. Well, how do we find S to the n? Here in black we have S to the n equals u1 plus the quantity n minus 1 times d. In black there, that's just the formula for finding the arithmetic sequence. While in red you have to multiply your first term times 2 and then multiply the whole thing by n divided by 2. But it's easy to remember. If you remember this formula, just tack on 2 times n minus 2 outside. Alternatively, you can think of it like this. If you take your first term and your last term and you take your average, you're sort of going to get the mean term here. If you take the mean times the number of terms, that should give you the sum. So both of these are useful. Here is, again, this is for the sequence, times 2, the whole thing times n over 2. Or you can think of it, take the mean of the first and the last, and then multiply by the number of terms you want. Let's do an example of arithmetic series. For the arithmetic progression 3, 5, 7, 9, 11, 13, etc., find S20, the sum of the first 20 terms. That's a series. Well, we know this is our formula. S to the n equals n over 2 times 2 times the first term plus n minus 1 times d. This part of it just being the arithmetic sequence formula. So it's just a matter of plugging and chugging. If our n is 20, it goes 20 over 2 times our first term is 3, n minus 1 is 20 minus 1 is 19 times 2. The rest is just algebra. And we find the first 20 terms sum to 440. How could you do it by hand? Of course you could do 3 plus 5 plus 7 plus 9 plus 11 plus 13, all the way out 20 times as well. The same arithmetic series problem can be done with the other formula I talked about. For this arithmetic progression, 3, 5, 7, 9, 11, 13, find S20. Well, we know S to the n is equal to the average of the first term and the last term of our sequence divided by 2, or our series, whichever. Well, we know our first term is 3. What's our last term? It's going to be, if we're looking for S to 20, it will be, just use your formula you learned earlier for sequences. U to the 20 equals your first term, u1, plus n minus 1 times d, and you get 41. You can now plug 41 in there, plus your first term divided by 2. You get an average of the first and last terms is 22, times 20, which is the n, gives you also 440. Why do you use this formula? If they give you the first and the last term, it's convenient to use this. Otherwise, you can still use it, but you know you have to calculate the value of that last term in the sequence or the series. Here's an example of an arithmetic series. It says straight up to you, an arithmetic series has a third term of 0. The sum of the first 15 terms is negative 300. What is the first term and the sum of the first 10 terms? Well, I've written the pertinent equations, or the pertinent formulas on the board. First, we know that the nth term is u1 plus n minus 1 times d for an arithmetic sequence, not the series. But that will help us because it says the third term is 0. Well, that means u3 equals u1 plus 3 minus 1 times d, and that third term is equal to 0. So I set that equal to 0, and I get u1 plus 2d equals 0, just from the information that the third term is equal to 0. That means plug a 3 in for n and set it equal to 0. Well, I do know that the sum of the first 15 terms is negative 300. So I know that I take my formula for the sequence, multiply the first term by 2, and the whole thing by n over 2, and I get the sum of the first n terms, which is the series now. Well, it tells me if n is 15, then the sum is equal to negative 300. So I plug in a 15 for n, a 15 for n, and I set it equal to negative 300. When I distribute out and simplify, I get 15u1 plus 105d is equal to negative 300. I divide each and every term by 15 to make it a little easier for me. u1 plus 7d equals negative 20. That's just simply this equation divided by 15 all the way through. That gives me these two equations, which I can solve simultaneously. When I set my two equations over each other, I can multiply the bottom equation by negative 1, giving me the same first equation, u1 plus 7d equals negative 20, and this now distributes to each and every term, so I get negative u1 minus 2d, negative 0 stays the same. The u1's will cancel, 7 minus 2 is 5d is equal to negative 20, divide both sides by 5, I get d is equal to negative 4. I think this equation is a little easier to work with, so I just wrote u1 plus 2d equals 0 again. I substituted for d, and I found u1 equals 8. I've answered half of my question. It said find the first term, which is 8. Now all I have to do is find the sum of the first 10 terms. We just found out that u1 is 8, and we found that our d was negative 4. So now we're ready to answer the second part of this question. What's the sum of the first 10 terms? We know that SEN is n over 2 times the quantity 2u1 plus n minus 1 times d. It's just a matter of plugging and chugging. Our n is 10, so it's 10 over 2 times 2, our u1 is 8. 10 minus 1 is n minus 1 times our d is negative 4. Clean this up in the parentheses. 10 over 2 is 5. Eventually we'll get s to the 10, or the sum of the first 10 terms is negative 100. Here's another example with an arithmetic series. It says, a new business is selling home computers. They predict that they will sell 20 computers in the first month, 23 in the second month, 26 in the third month, and so on in arithmetic sequence. How many months will pass before the company expects to sell their 1,000th computer? Well, the hard part of this problem is recognize that you have an arithmetic series on your hands. We have to sum 20 plus 23 plus 26, because that's the total sold up to date. And so in red there, I wrote the formula. S to the n is equal to n over 2 times your first term, u1, plus n minus 1 times d. And we want to know when that's equal to, or greater than equal to, if you like, an inequality, to 1,000. Plugging and chugging, I just have to plug in. I know my first term is 20. I don't know how long it's going to take. I don't know how many months it's going to be. But I do know that I'm going from 20 to 23 to 26. So my d is 3. When I distribute out this 3 and then multiply both sides by 2 to get rid of that fraction. First I distribute and then I multiply by 2. Eventually I get n times 37 plus 3n is equal to 2,000. I got rid of that 2 by multiplying by 2 on both sides. So as we continue on with this problem, we have to distribute out this n. And if we have n squareds and n's with the number, put everything on one side by subtracting 2,000 from both sides. Try to factor it, it doesn't work. We certainly, if it's on a calculator paper, can graph it and find the x-intercept, or use the solve n feature of our calculator. If not, we can go to the quadratic formula, which says n is equal to negative b plus minus the square root of b squared minus 4ac all over 2a, where a is equal to 3, b is 37, and c is negative 2,000. Don't forget that's a negative there. Well, when I plug this into negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, when I solve for n, I get negative 32.7, and that can't be true because we're talking about the number of months. It has to be positive, and 20.4. So after how many months? Well, to our closest month, we have to go to 21 months before we're greater than or equal to 2,000. So that is the correct answer.